Welcome back, everyone. We're going to talk a little bit about finding probabilities with normal distributions. And with that said, let's go to it. I hope you remember what you learned back in 5.1 because we're going to use that and extend it further, but there will be some review as well. That said, let's get with it. All right. Just a reminder, we've already discussed 5.1. Check that off. Unless you want to review, we're going to talk about 5.2, finding probabilities, and just a little bit of a reminder, 5.5 is not somewhere we're going to go. We're going to find probabilities, but first of all, remember, you have to see what you're working with. It has to be normally distributed. Otherwise, stay away. Remember, there are binomial distributions and others, geometric, for example. And we're going to use the TI-84 pretty much exclusively, unless you've got a TI-Inspire. If you've got the TI-Inspire, you know that I like that. But anyway, you don't need one. So here's what one looks like. And you can find the probability by calculating the area. So what you've learned about area converts to finding probabilities, assuming that it's a normal curve for that interval. Remember, this is one we talked about earlier. Almost, except this one, this normal curve has a mean of 500 and it has a standard deviation of 100. So 100 away and 100 away, and you're talking about 68% of the area. Well, that means that the chance of getting a result at random somewhere in this region would be 0.68 roughly. The probability X is in that area, plus or minus 1 standard deviation. All right, so let's get with it. Let's suppose we do have that normal curve with a mean of 500 and standard deviation of 100. Find the value of X, 1 standard deviation above the mean. Well, here's your formula. If you want X, just take the mean, add the standard deviation, and you've got your X score. Now this really corresponds to Z equals X minus mu over standard deviation. Very close. This might be handy to remember. But remember, the X score will be either to the right or to the left of the average or the mean. And your standard deviation could be positive in this case, or it could be negative. In this case, adding the standard deviation gets you up 100 in this case to 600, and that's your X score. Now let's look at the standard normal curve because that's what we've worked with so far. This, you might say, is for X's, and this is for Z's. Remember, the Z's are the number of standard deviations, right or left. So 1 standard deviation above the mean, you just take the mean, add 1, and there you go. That's your Z score or Z value. Now, Z score of 1 corresponds to an X value of 100 because it's 1 Z or 1 standard deviation, and it's a plus so you add it to the 0. Now let's get a chance to play with this. That's the only way you really learn this. And remember, if you want to try it yourself, you can always hit that pause button, the space bar, and see if you can work this yourself. Now maybe not on the first one, but maybe you could, because remember, probabilities and areas under the normal curve are basically the same thing as far as numbers are concerned. So the first thing you need to do is collect. Collect the information you've got so far. We want it all in one place. We don't want to read through all of this multiple times. Maybe 2 or 3 times, but not all the time. So what I do is I create a scratch area for myself, or information area. The first thing I see when I read this is it says a national study found that college students with jobs worked an average, so we're talking about a mean, of 25 hours per week. I want that right in front of me. Then it says the standard deviation is 11 hours. I'm going to put that down here. 11 hours per week. Now, we pick a college student at random. A college student, we're picking one. Now in the future somewhere, I'm not telling you where, we're going to talk about picking a bunch of them, a sample of them, and finding their average. But we're talking here about picking one college student at random. We want the probability that that student has less than 5 hours per week. Now once I've got that, and I might actually put that in here, probability that the x we get, that variable for him will be less than 5. So everything is right there. Well, what am I going to do next? Once I've collected the information, you know what I'm going to do. I'm going to draw a picture. You've heard that before, right? Well, it's good information, and I'm going to put 2 things here. First of all, I'm going to put the x-score on one axis, and I'm going to put z-scores on another axis. This isn't a minus sign, it says z, sorry. Since this is a z-axis, we know that this is going to be 0 because that's a normal distribution. The x, I do know what this will be, because this is the mean right here in the middle. And down here in my info section, I've got 25. So the x value right here in the middle is 25 hours per week, which corresponds to the z of 0 right in the middle. And what do we want? We want the probability that the person we pick works less than 5 hours a week. So what's this going to look like? Well, this 5 is an x value, a straight value. And since 25 is right here, that means 5 is over here somewhere on the x-axis. And what we want is x less than 5. So where is that area? Where is that probability? Back here. And we've done something very similar to that before. So what we're going to do is, as we did in the last section, I'm going to go to normal CDF, and if you've forgotten already, you go to second vars to get to the distribution menu. The first parameter, or the first option, is where do we want to start looking for the probability? Well, if you look at your picture again, the picture is going to tell us negative infinity. And remember my sneaky way of doing it? Well, we'll get to that in a second, just in case you forgot. We're going to start at negative infinity, and we're going to go up to 5. Now this time, we're not talking about the standard normal. We're talking about a regular normal distribution. So we need to tell what the mean and the standard deviation are. So for this particular normal distribution, we've got a mean of 25 and a standard deviation of 5. Now, how am I going to put it in? Just in case you want to follow my way of doing things, I'll go to normal CDF at second bars, and I'm going to put it in negative 9, 9, 9, 9, and double check. Is that way to the left of the 25 and the 5? Yes. It's nowhere close. That's the important thing about this sneak number here. And where do we want it to stop? We want to start collecting the probabilities at 5. Which distribution are we talking about? The normal one that has a mean of 25 and a standard deviation of 5. And if you put that in your calculator, maybe you want to hit a pause here. Try it yourself on your calculator, because you've got everything you need here. You know how to find that area, or that section. Here we go. Now, this is the old way of doing it. The old way is you take these x values, where am I? You take these x values and turn them into z values. Well, there are two values we're interested in. The mean for this one is 25, which corresponds, of course, to a z value of 0. The standard deviation for this one is 5, and that is a standard deviation on the z curve of what? Well, we'll find out here. Put the 5 in here, subtract the mean from it, divide by the standard deviation. Okay, I think we've got a small mistake there. Let me check here real fast. My mistake. Standard deviation is 11. Well, we all make mistakes, don't we? So we need the 11 here, and just quick use of the calculator, that is our z-score. So if we want to, we can actually put it in this way using z-scores. However, we don't really need to. That's using old technology. We're a lot more futuristic than that. So we're going to use this one. So normal CDF at second bars, also known as distribution. We want to start at negative infinity. I'm going to put negative 99999, which should suffice. Where do I want it to stop? I want it to go up to, but not including 5. So negative infinity to 5, because we're talking about less than 5. Which curve are we actually talking about? We don't have to stick with the standard using z-scores. We can just put these in directly. The mean is 25, the standard deviation is 11, and there's my answer. What is this? Remember, this is the probability that the random student we pick works less than 5 hours per week. There you go. You can become an expert at this, don't you think? So remember, this number right here, if we convert that to a percent, we've got our answer. About 3.34% of college students with jobs work less than 5 hours per week. And because it's less than 5%, it's unusual. Now this is important because if someone says, this happens all the time, doesn't it? You can say, no, it's less than 5%. 5% is another sort of gold standard. We use 5% a lot, or 0.05. Less than 0.05, if happening less than 5%, is not very often. It's less than 1 in 20. So there you go. Shall we try another one? Why not? Let's see if I can get all the numbers right this time. All right, first of all, I want to collect that information. It says a trip to the supermarket, a shopper in general spends an average of 41 minutes. So there's my mean, 41 minutes. By the way, take notice that the mean and the standard deviation do have units. And this is a good place to put it so you don't forget. It says a standard deviation of 12. So the standard deviation is, 12 minutes. So here's our information. We can see it real easily. We don't have to read the paragraph multiple times. What do we want to find? Well, first of all, we want to find out whether it's normally distributed. That's very important. It is, so we can check that off. So we can go using normal CDF, for example, on our calculator. Part A, what are we looking for? We're finding the probability that the shopper will be in the store for the interval of time listed below. I guess we're going to get that soon, right? And second, we're going to find when 200 shoppers enter the store, how many do you think will be in the store for that interval of time? So, let's see. Okay, I sort of messed this up. I didn't have my ESP working. So the first part, what are we looking for? We're looking for the probability that the person we pick has shopped between 20 and 50 minutes. That's what we're looking for. And then for part B, we're going to ask ourselves, if 200 people come into the store, what is the probability that they'll shop between 20 and 50 minutes? Oh, let's figure this out. So, first of all, between 20 and 50. Well, you know we're going to use normal CDF, second bars or distribution. And we want between 20 and 50, those are the lower and the upper bounds. So put 20 for the lower bound, 50 for the upper bound. And what curve are we talking about? We are talking about a normal curve. And that particular one has a mean of 41 minutes and the standard deviation of 12. And that will give us this result. We'll see it in a minute. Now, how are you going to get the second one? It seems like this is something we haven't done before. Well, you're right, but it's actually pretty easy. Once you've gotten this result up here, all you need to do is multiply that by the 200 to get how many you expect. So we'll take this 200 and multiply it by what we just found. The normal CDF, 20, 50, 41, 12. That will give us that one. What else do we want to do? Well, actually, there's a second thing we want to do. Suppose we have some shoppers coming in. What's the probability that one of those shoppers stays more than 35 minutes? Well, Draw a picture like we should have back here. Draw that picture. Remember that the 41 is in the middle, the 20 is back here, and the 50 is out here. And we want the area from the 20 to the 50. That's how we got this. Now how do we do this one? This one will be smarter. Here's our 41 in the middle. We want it greater than 35. 35 is back here. We want greater than that, so we want all the area or probability to the right of 35. So what do? Excuse me. We're going to use normal CDF again. Remember, don't accidentally use option number 1. This is option number 2. Just a reminder, we're talking about negative infinity. Oops, greater than 35. So we're going to start at 35. We'll go to positive infinity because there is no upper limit. And you know what I'm going to do? I'm going to just put a bunch of 9s in here and double check myself. Are those 5 9s and 99,999 way above the 35 and the 41? Yes. Which normal curve are we talking about? We're talking about the one that has a mean of 41 and a standard deviation of 12. So that's going to give us the probability that that next person that comes into the grocery store is going to be there for more than 35 minutes. Now, there's a second part to it, remember? The second part says, if 200 come in, how many of those are expected to be staying there for over 35 minutes? So again, like the other one, we'll multiply by that 200 times the normal CDF. And just copy this. This will give us our probability. And this will give us how many shoppers out of the 200 we expect to stay for over 35 minutes. Now again, remember, the old way of doing this was to change these numbers, the 20 and the 50 in our first example, to z-scores. This is a little bit questionable for us because we don't need to. We can get there in half the time or less by using normal CDF on the TI-84, and that's what we're going to do. At least that's what I am going to do. So there's my normal CDF. Start at 20, go up to 50. There's the curve we're talking about, a mean of 41, standard deviation of 12. And if you use the z-scores, you'd be doing it like this. And since you switch to z, it'd be 0 and 1 out here. And there's the probability that the next person coming in is going to be there for between 20 and 50 minutes. And if 200 come in, how many do you expect to stay between 20 and 50? Well, just multiply that probability times 200. And we'd expect about 147 shoppers. Will that be exact? No. It'll probably be more than that, more than less than that, but we expect to be somewhere in that vicinity. The second one, remember, we're talking about the probability that we have more than 35 minutes for the next person that comes in. Here's how you could calculate the z-score if you need it. However, we don't really need that, but we do need to stay organized. We want this person that comes in to be staying 35 or more. There you go. If you use the z-scores, it would look like that. Z-scores, you do it like this, but I don't think you really want to do that. So we're going to sort of semi-scratch this off. We're going to put it in directly like this. because we want 35 minutes and up for that next customer. And the probability is 0.69, or about 69% of the time that the next person is going to stay there 35 minutes or more. So how about if 200 come in? How many do we expect to stay 35 minutes or more? We'll just multiply that by 200. And if 200 come in, we expect about 138 to stay 35 minutes or more in the store. Catching on? You'll get more practice with the worksheet that I've given you. This should get you off to a good start. Another way you could do it is go back to the beginning of this lecture and try the examples yourself before they're actually shown to you. Here's another example we can use to play with. First of all, let's get the details up here. I'm going to put them at the top. We have a mean of 280 physicians. And important, they're normally distributed. If they're not normally distributed, we're not going to do this one. However, they are, and the standard deviation that goes along with this situation is 78 physicians. Now, what do we want? We're looking for, if you randomly select a state, what's the probability the state has fewer than 300 physicians per 100,000? So what do we want is the probability, and you want the probability that the concentration of physicians in that state is less than 300. And I'll just shorten that to physicians. That's what we're looking for. What am I going to do? I'm going to sneak my picture in here. What's in the center? The center is the mean, which is 280. The standard deviation I'll put in like this. 78, which of course you know also goes in the other direction. That's the standard deviation, so everything's there in the picture. Now what are we interested in? I'm going to have to draw a second picture or use a different color. I'm going to stick with drawing another picture, but I'll put it right below so you can see the comparison. Now we're talking about 300 this time. So where's 300? Well, 280 is here. So there's the 280. And 300 will be somewhere out here. And what does it say? Find the probability that they're less than 300. Less than 300 means we're talking about the area / probability in that region right there. So how do I get that? Well, where am I starting? Well, I know I'm going to use normal CDF. Reminder, you can only use this if it's normally distributed, which it said it is, normally distributed. Normal CDF, where do we start? Well, I look over here, negative infinity. I'm going to use my hack here to make it easy to type. I want to go all the way up to 300. Which distribution are we talking about? The normal distribution that has a mean of 280 and a standard deviation of 78. I'm ready to go. All I have to do is grab my calculator, go to second bars, and you don't need those z-scores, but just in case someone does, but this is the way we're going to do it. There's our lower bound. Here's our upper bound. Here's our mean. Here's our standard deviation. And there's our probability. That's what our calculator should look like. And there's our basically 60%. So there's our answer. And here's how we would state our answer. The probability that the state has fewer than 300 positions per 100,000 is about 60.1%. Well, that's it. Not too many slides on this one. So we're wrapping this up pretty early. So, way to go, folks. You made it through another section. We'll see you in the next one.